given that cosine is 5 over 13 and theta is between 3 pi over 2 and 2 pi, that just tells us we're in quadrant 4. Find sine 2 theta, cosine 2 theta, and tangent 2 theta. So first thing I'm going to do is I'm going to draw this. If our angle is in quadrant 4, so here's our big angle, they tell us the cosine, if this is theta, then here's theta prime, and we're going to put our eyeballs looking through theta prime. So notice my triangle, here's my angle, there's the terminal side of my angle. My triangle, I go up from the unit circle, up, it's the unit circle, so I'll call that 1. And my triangle always involves the x-axis there. So from this angle's perspective, cosine, so katoa, they're telling me adjacent over hypotenuse is 5 over 13. Now, I could have made this 5 over 13 and 1 and kept it on a unit circle, but I decided not to. So this is not a unit circle. 5 something 13. Oh yeah, I know my Pythagorean triples. So this is 12 here. But to go from 0, 0, right and down, this has got to be negative. In this quadrant, quadrant 4, A, S, T, C. The sine is negative and the cosine is positive. That's x is positive, sine, y is negative. So now I'm ready to go. Sine of 2 theta is equal to 2 sine theta cosine of theta, which is equal to 2 sine of an angle is a ratio, cosine of an angle is a ratio. From this angle's perspective, remember we use theta prime, that's the reference angle, always positive, just like our hypotenuse, stuck between the terminal side of our angle and the x-axis. So we're going to look through theta prime to figure out the ratios for theta. Sine is opposite over hypotenuse, negative 12 over 13. And cosine was given, adjacent over hypotenuse, 5 over 13. Well, this is going to be 13 times 13 is 169. And 5 times 12 is 60, times 2 is 120. Positive times negative is negative. So I've got my fraction for sine of 2 theta. Cosine 2 theta, I know, is equal to cosine squared theta minus sine squared theta. Maybe that's a good one to use. Or it's equal to 1 minus 2 sine squared theta. Maybe that's a good one to use. Or maybe 2 cosine squared theta minus 1 cosine 2 theta. It really doesn't matter which one we use. Let's use the first one. Sometimes it matters, especially when we're doing proofs, which one we use matters, but they're all equal to each other. So whatever cosine is, that's a ratio squared, minus whatever sine is, ratio squared. Some students get this wrong. Cosine squared theta plus sine squared theta, that's the first Pythagorean identity. That's 1. But cosine squared theta minus sine squared theta is cosine of 2 theta. So cosine squared theta is 5 over 13. 5 over 13. And I'm going to square that. And sine squared of theta, well, that's going to be whatever sine is squared. And sine is negative 12 over 13. So I'm going to get 5 squared is 25 over 169 minus, well, negative 12 squared is 144 over 169. So now you've got to think to yourself, what is 144 minus 25? That's 119. A big negative plus a small positive is going to give us negative 119 over 169. Now, if you had used any of the other two formulas, you would have gotten the same thing too. Really, I couldn't see one being much easier than the other, so I just decided to use the first one I came to. But sometimes one is easier than another. So that sort of guides my philosophy. On a proof, one is most appropriate, more so than the others. But if I'm solving a problem like this, I'm just trying to figure out which one will give me the least amount of work. We know that tangent 2 theta, we only have one option, is 2 tangent of theta over 1 minus tangent squared theta. So this will give us 2 times whatever that ratio is over 1 minus that same ratio squared. Putting our eyeballs looking through our reference angle, we know that the tangent is opposite over adjacent, or negative 12 over 5. And here we have negative 12 over 5. So this will give us 2 times negative 12 is negative 24 over 5 in our numerator, divided by, here we'll have 144 over 25. 144 over 25. Now, that negative times negative is a positive. This negative comes out in front. And I'm going to write this as 25 over 25. That 1 became 25 over 25, which gives us negative 24 over over 5. Sorry about that. Over 5 over, well, 25 minus 144. We just saw that. That's negative 119 over 25. Of course, we're going to want to keep change flip here. So keep the numerator, negative 24 over 5. So I'm keeping this, change division to multiplication, and now flip this. This will be 25 over negative 119. So 5 goes into 25 5 times. Negative times negative is positive. 24 times 5 is 120 over 119. And now we've got our answer.